Our story begins a long, long time ago, about 4.6 billion years. This was a time when the universe was still young and the Milky Way galaxy was bustling with activity. Imagine a giant cloud of gas and dust floating in space. This cloud, known as a nebula, was the birthplace of our solar system. It was cold and dark, and everything was calm and quiet. The particles within the nebula were drifting aimlessly, waiting for something to happen. But then something spectacular happened. A cosmic event that would change everything. A nearby star exploded in a supernova, sending shockwaves through the nebula and giving the cloud a big push. This push made the cloud spin and collapse in on itself. The once calm and quiet nebula was now a swirling, chaotic mass. As it spun faster and faster, it got hotter and hotter in the center. The intense pressure and heat were building up, setting the stage for something incredible. Eventually, the center became so hot and dense that it ignited, creating a brilliant star, our very own sun. This was the dawn of a new era. But the story doesn't end there. The formation of the sun was just the beginning. Left over from the sun's formation were bits of dust and gas still swirling around. These remnants formed a protoplanetary disk, a nursery for future planets. These tiny particles, like cosmic dust bunnies, would eventually come together to form our planet and its solar system neighbors. Over millions of years, these clumps grew larger, colliding and merging to create the planets we know today. Imagine those tiny particles of dust and gas swirling around the newborn sun. In the vast expanse of space, these minuscule particles seemed insignificant, but they held the potential to create something extraordinary. They bumped into each other, and because of gravity, they stuck together. This process, known as accretion, was the beginning of something much larger. Over millions of years, they grew bigger and bigger, like a snowball rolling down a hill. Each collision added more mass, and the clumps became more substantial. As these clumps grew larger, their gravity became stronger. This increased gravitational pull allowed them to attract even more particles. They pulled in even more dust and gas, growing larger still. This relentless accumulation of material was crucial in forming the building blocks of planets. These giant clumps of matter eventually became the planets we know today, including our own Earth. Each planet had its unique journey, shaped by the conditions in its part of the solar system. At first, Earth was a hot, molten ball of rock. The surface was a fiery, chaotic landscape, constantly reshaped by volcanic activity. But over time, something amazing happened. The Earth began to cool down. This cooling allowed the surface to solidify, forming the first crust. This cooling process was the key to the next stage of Earth's evolution. It set the stage for the development of the planet's geological features and eventually the conditions necessary for life. As Earth cooled, something like separating salad dressing happened. The heavier elements like iron and nickel sank towards the center. The lighter elements like silicon and oxygen stayed closer to the surface. This process, called differentiation, is how Earth got its layers. Think of it like a giant layered cake. The heaviest layer, the core, is at the center. Around the core is the mantle, a thick layer of hot rock. And on top we have the crust, the solid surface we live on. Each layer has its own unique properties, but none are as important or as mysterious as the heart of our planet. Section 4. The heart of our world. Deep down below the surface, over 1,800 miles down, lies the Earth's core. It's about twice the size of the moon and as hot as the surface of the sun. The core is made mostly of iron and nickel. The outer core is liquid metal, constantly flowing and swirling. The inner core, even though it's hotter, is solid because of the immense pressure from all the layers above it. This incredible heat isn't just coincidental. It's the engine that drives many of the processes we experience on the surface, from volcanoes to the very ground we walk on. Section 5. A core issue for life. The Earth's core is essential for life as we know it. It plays a crucial role in maintaining the conditions that allow life to thrive on our planet. The constant movement in the outer core creates a magnetic field that surrounds our planet. This magnetic field is vital for many reasons, including navigation and protection. This magnetic field acts like a giant shield, protecting us from harmful radiation from the sun. Without it, Life on Earth would be exposed to dangerous levels of solar radiation. Without the core and its magnetic field, the sun's solar wind would strip away our atmosphere, leaving Earth a barren and lifeless wasteland. The atmosphere is crucial for maintaining the climate and weather patterns that support life. Our planet would be like Mars, a cold and dry planet with no signs of life. Mars lacks a significant magnetic field, which is one reason it cannot support life as Earth does. So, the next time you feel the ground beneath your feet, remember the incredible journey Earth has taken. The ground you walk on is a testament to the dynamic processes happening deep within our planet, and be grateful for the hidden heart of our planet, the core that makes life on Earth possible. It is the unseen engine that drives the conditions necessary for our existence.